Welcome to part 4 of the series on recursion. Now, this video we are going to look into a few more interesting problems in recursion. We're going to look into a function that removes all occurrences of an atom from a list. We are also going to look into a function which substitutes all occurrences of an atom O with a new atom N. We are then going to look into how to achieve these two functions using a common function called match in a very functional programming way, and we are going to use a higher order. Match is going to be a higher order function to be able to achieve this. So let's get started. So the first function we want to write is remember, which removes a member from a given list. So as usual, our end condition is going to be, if the list is empty, we return the empty list. So we can go only step by step in this array. So the first step will be to extract the first element of the array and the remaining elements. Now that we have the first element of the array, what we want to do is we want to check if it's equal to k, the item that we are looking for to remove. Now if it is equal to k, then we don't want to include it in the array, but then we want to proceed with the next set of uh, atoms in the array, atoms in the list. But it's not just that we want all the items in the array, but what we want is we want to remove any more occurrences of k in the remaining set of elements in the list as well. So thus we have to recursively invoke a remember on the remaining list x's, and whatever result we get, that we expand into the array. Otherwise, if x is not equal to k, obviously we retain x, but then again continue to apply remember on the remaining elements. Now if you see, this is very similar to mult. So instead of multiplying, what we are doing here is we are either retaining it or we are not retaining it. Cool. So now let's see if this works. And let's say we want to remove 3. Not passed k here, which should have been undefined. I forgot to pass k here, and that is why it was not working, because in the next stat k was coming as undefined and it was not removing it. So yeah, now it should work. Yeah, so that works. 1 2 4 5 6 7 3 is removed from this. Now another function which is very similar to this is we want to see, so instead of removing an occurrence of atom O, we want to replace it with another atom N. So this will be very similar to remember. So let's see how to do that. So const subs equal to S, the list O, which is what we're looking for, and replace it with N. So our end condition, we always start with the end condition, is if the list is empty, we return the empty list. Now we need to get access to the first element of the array, and once we have got access to the first element of the array, what we need to then check is it equal to O, that element that we are looking for. If it is equal to O, then we want to replace it with N. Thus, instead of X, we have now got N. But then again, we want to continue to substitute any more occurrences of O in the remainder of the list. If X is not equal to O, then we then we retain it. We retain X and then continue to look for O in the remainder of the list. Again, if you think about it, substitute is very similar to remember. The only difference is, instead of removing it, we are substituting that element with another new element, or as seen here, retaining that element. And if you think about it, all these functions, mult and multif and remember and substitute, are very similar in structure. So that again gives us an idea. I mean, if you think about it, we externalized the condition evaluation in multif to make it generic in such a way that you could pass any condition and then let it multiply, let the element evaluate the condition and then only multiply the elements of the array if the condition is evaluated to true. So we did that with multif. Now if you look at the structures of all these functions, they are extremely similar in structure. So is it possible in such a way that we can write one function and somehow pass the operation that differs among this as a function, so trying to separate out what changes from what remains constant. So now let's see what's changing here in this and what is remaining constant. So if you consider multif, so this logic of checking if the list is empty and then breaking down the list into first element and the remainder of the list is same for all the functions, all these 4 functions. But what is different is some condition evaluation. So here we are checking if count of x matches. Here we are checking if x is equal to k. Here is checking if x is equal to O. So the condition we are checking is changing, and if the condition matches, what we are doing after the condition matches is changing. So here we are multiplying and then continuing to evaluate. Here we are completely removing it. Here we are substituting with a different element. So what we are doing after the condition, is also changing. So now that gives us an idea. What if you could what if you could take the condition evaluation as a parameter like we do in multi-if. Also, what if you could take what we do after the if condition evaluates to true, even that as a function. What if we could ask the people who are using this common function to give us the result of applying the condition as well. So let's see how we can do that. Now imagine that not let's see how we can do that. Let's say we have a function called match. We take a list, now the first condition remains the same. The end condition, we check if the list is empty, we return it. Otherwise, we break it down into the first element and the remainder of the list. At this point, what we want to do is we want to do two things. We want to evaluate the condition, and if that condition matches, then either we have to multiply or we have to remove the element or we have to return some other element in place of that. So all we are doing is we are replacing x either with some new element or with no element or with a multiplication or with some constant. So what if we had a function called replace which did this for us? Now we'll come to how it might do it later, but let's say we had a function called replace which we passed x to s, and it also decides whether to replace it or not. So let's say if x was equal to O, it would have replace it with n, but if it was not equal to n, then it can just return x instead of returning n. So that will allow us to code substitute. So let's see how replace could work for remember. So if x was equal to k, then it could return null, which is then like a no member, no result, or it could return x, which is it's not to be replaced, or it could return multiplied by a constant, or it can return x. So essentially we call replace on x. Now replace can decide whether to replace it with x or replace it with something else, whatever it is, like a multiple or a new value or whatever, or return the same value, deciding not to replace it. So given this, now we can check if, so because in the case of replace it can return a null, indicating that there's no value to return, we need to check if r is equal to null. So if r is not equal to null, we want to replace, instead of x, we want to replace it with r, and then continue to apply the match function on the remainder of the list, and also pass the replace function to match. Whereas if r was null, then obviously we can't include it, but then just continue to invoke match function of the remainder of the list with the replace function. So okay, now instead of using this variable, we can just let's retain this. Sorry, we need that because it's used in multiple places. Our result is used here and here, so we need that. So let's see if this works. Now let's see how to code multif which is, let's say, multiply by even number, so which is a function which behaves like multif but only multiplies even number. Or let's go ahead and try to code multif itself. Say s, so I'm calling it as multif version 2. Takes c, which is the constant, and takes con, which is the condition. Now we want to invoke the match function, pass yes to it. Now here we code the replace function. Now replace receives x. Once we get x, what we do is we pass it to cond and evaluate it. Does the condition match? Now if the condition matches, we want to multiply it with the constant c. Otherwise we want to return x. So let's see if this works. 1, 2, 3, 4 multiplied by 100. The condition is that x has to be an even number. Cool. That works. Cool. So we have come up with an version of multif using the match function. Now let's code rember using match. So match s. Now the replace function gets x. Now if x is equal to k, then we want to return null because we want x to be replaced. Otherwise we return x. So this is where this null check becomes important. Now let's say if rember version 2 works. I want to get rid of 3. Okay, and that works. Now as you can see, it should be very intuitive and very easy to code version 2 of substitute as well, which uses match. Yes, and if x is equal to k, rather O and n, so if x is equal to O, old value, we want to be replaced it with the n, whereas if it's not, then we want to return x. So now let's see if v2 works. So instead of 3, we want to put 100. That works. So as you can see, we have come up with this incredibly generic function called match, which essentially then goes to evaluate the replace function on each element. Now the replace function is takes x and then decides whether it has to replace x or not. If it has to replace x, it will also return what has to be replaced it with as well. It could return null, and that is why we check for null, and if it's not null, then we include it and then continue to invoke match function on the remainder of the list. If it is null, obviously we don't include it, and then continue to evaluate the match function on the remainder of the list. Now match is a higher order function which takes replace, which is a function, as an argument, and then uses it to decide whether to replace x or not, or to and to get, if it has to be replaced, to get the value of what it has to use instead of x as well. So in the next video we are going to uh, do few more interesting things, solve a few more interesting problem. One is how we can solve for, first of all, find an occurrences of an atom O and then insert an atom N after it to the right of the O in the list. Insert L will do the same thing, but will find occurrences of an atom O in the all occurrences of atom O in the list, and but then insert an atom N before it to the left of the O. So after we implement these two, we are going to modify the match to work with insert R and insert L as well. So once we do that, we'll have to change our implementation of version 2 of mult v2, the version 2s, the version 2 of multif, rember and subs as well. So let's look at that in the next video. Thank you for watching.